All right. Good morning, Lorenzo. How are y'all doing? Good. Um, I apologize that I was not here on Fridays. Um, I have just not been feeling well. I'm going to go see the doctor tomorrow. Hopefully, he can give me something that will help me feel better. Today's agenda is to address your questions over assignment 6. If you have any lingering questions over assignment 5, I'll be glad to answer those. I have graded your quizzes. Those quiz grades are up in Blackboard. Be sure to click the link next to your grade, and that will take you to your graded quiz in Gradescope, and you can see any of my annotations or any comments that I made on your quiz. There's just a little link next to your grade that you can click, and it'll take you to that graded quiz. Um, because of some technical issues that I only got resolved over the past weekend, um, I haven't gotten around to getting your weekly assignments graded, but I hope to do that tomorrow or at some point today. Um, Before we get caught up with answering questions over the homework, I want to say a couple of things. Number one, um, my plan is to be here all this week, Wednesday and Friday. Even though on the calendar I say that we do assignment 6 both today and Wednesday, I would consider taking a look at assignment 7 before Wednesday. And if you have any questions over assignment 7, we can address those on Wednesday, just in case um, it gets to the point on Friday where I just cannot come to class again because I'm just not feeling 100%. We can do a repeat of what we did last week, where you just come in and take your quiz, and I'm just not physically here. So plan on just having those questions ready for Wednesday over assignment 7. Next week is our first exam. We'll do a review. We'll answer any questions that you want on Monday. And then we'll have Wednesday and Friday to take our exams. Remember, the exams are going to be given in 2 parts, where you have part 1 on Wednesday, where you have all of Wednesday to get part 1 done. And then on Friday, you'll come back and you'll do part 2. All right. I think that's all the announcements that I have. If you hear clicking in my mouth, I'm sucking on a cough drop. It seems to help. All right. The floor is yours. How can I be of assistance to you?
Can we go over 9?
From assignment 6?
Yes.
Okay. Number 9. Okay. Couple of things that we want to make note of is first one, if you have the square root of b and you square it, you get just b. Essentially, you can think that the radical and the exponent of 2 cancel out. So, what we want to do is we want to start getting rid of the radical. So we're going to square both sides. Now, on the left-hand side, we can just say that this is just x plus 5. But what you got to be aware of is that on the right, this is a binomial that you're squaring. So we have to think about this as set of parentheses times itself. And we're going to have to go through and FOIL. Okay? So let's get those arrows drawn up. Gives us a bit of direction. Two times 2 is 4. 2 times this radical is 2 times the radical. We do not distribute into the radical. Radical times 2 is again 2 times the radical. Then radical times the radical. Alright, with me so far? Okay. So, a couple of things are going to happen. We can combine those two terms, and we get to apply our thought up here of how to get rid of the radical right here. So we're just going to add the coefficients together. Alright. Now, what we've essentially have gone and done is we have now gotten rid of the radical around the x plus 5, but we still have a radical, a square root, around this x minus 3. So what we want to do now is we want to work to isolate the square root of x minus 3. We want to work to get it by itself. Alright, so what can we do? Couple of things. Just going to clean up the right hand side. 4 minus 3 is a 1. Alright, look what happens. Subtract the x's on both sides, they cancel out. Subtract 1 on both sides, and you get 4 is equal to 4 times the square root of x minus 3. Now, this is problem number what? 9? I'm going to tell you right now, on problem number 10, you're going to go through and do the exact same work. However, on problem number 10, you're going to end up with an x over here on the right, and some constant. And also, you're not going to want to divide, like we're about to do right here on problem number 10. Problem number 10, you don't want to divide, but on this one, we do want to divide. Why do we want to divide? Because 4 divided by 4, we can divide both sides by 4, and it works out really nicely for us. and we get 1 is equal to the square root of x minus 3. Problem number 10 is not going to work out the same way. But at this point, we're on repeat mode. How do we get rid of the radical? We square it. Make sure to square both sides. Which then just means that x is equal to, add 3 to both sides, you get 4. Make sure to check. Plug it back into the original equation, do a mental check, and verify that it works, and it does. Alright, does that make sense? Any questions on that? Did I need to go back and explain something? Make sense? Okay. What else can we look at?
Can we go over 24?
24. First thing that we want to do, isolate the absolute value. Isolate the absolute value. Get that absolute value by itself. So what we want to do is we want to subtract 4 on both sides, and we get the absolute value of 4 minus 4 is 0. Always, always, always isolate. The thing that's causing a problem, the obstacle, this is the obstacle, this is the thing that we got to undo. Get it by itself first. And what we talked about in this section was the absolute value of b is equal to plus or minus b. So what we say is the following. This becomes either the 3x plus 2 is equal to 0, or the opposite of 3x plus 2 is equal to 0. Hold on. Hold up. Sorry. I said that wrong. Let me back up. Here's our statement. Note, if the absolute value of B is equal to, let's call it C, then B is equal to plus or minus C. Sorry, said that wrong. If the absolute value of B is equal to C, then B is equal to plus or minus C. So what becomes here is this becomes 3x plus 2 is equal to plus or minus 0. Now, because 0 is neither positive nor negative, we can just say that 3x plus 2 is equal to 0. So solve. And we're done. Little side note. If this had been the absolute value of 3x plus 2 is equal to, let's say, 4, then you would have gotten more than one answer. Because then we would set that equal to plus or minus 4, which then means you'd have 3x plus 2 is equal to negative 4, and you'd have 3x plus 2 is equal to positive 4. So then you'd have 3x is equal to negative 6, and then you'd have 3x is equal to 2, which then means that x would then be equal to a negative 2, and then x would then be equal to 2/3. But because this is set equal to 0, plus or minus 0 is just 0. There's not two different answers there. We only get one solution. Does that make sense? Okay. Remind me again, how many students are in Lorenzo? 4 or 5? 5? All right. On my screen, 4 students, okay. All right, I see all 4 of y'all. All right, how else can I help out?
$17.
Did you say 17?
Yes.
Now, the instructions say solve the quadratic type. So that gives you a clue as to how you're going to do this. But I want to know, why is this quadratic in type? Why is this a quadratic type equation. Why? And the reason that it is, it all has to do with the powers of your variable. Note that for ax squared plus bx plus c equal to 0, that if you take the x and you square it, you get x squared. If you take this x and you square it, you get x squared. So that's just a quick note. So can we say the same thing about this equation? What happens if I take x to the 1/2 and I square it? Well, that becomes x to the 1/2 times 2 over 1, which is equal to x to the 2 over 2, which is equal to x to the 1, which is equal to x. You take the middle term, middle variable, and you square it, you get the first variable. Again, if you take the middle variable and you square it, you get the first variable. That's what makes it quadratic in type. It fits this same thought process that we have over here. So, that's why it's quadratic in type. We know that to solve quadratic in type equations, we use a substitution. So what we're going to do is we're going to let u be equal to x to the 1/2. So u squared, so if we take x to the 1/2 and we square it, we already know what that becomes. That becomes x. So we're going to replace our x to the 1/2 with u and our x with a u squared. And we then get the following. Which we can solve for u. With me to this point? Okay. I would factor, and you could use a quadratic formula if you want to. That's the factored form. So that tells me what u is. That's great. I want to know what x is. So we're going to come back and apply our substitution. This then means that x to the 1/2 is equal to 1/2, and x to the 1/2 is equal to 1. So how do we solve this guy? Well, recall that the square root of, x to the 1/2 squared is equal to x. So we're going to square both sides. So that gives us x is equal to 1/2 squared. 1/2 times 1/2 is 1/4. And 1 squared is 1. Does that make sense? Okay. Were there any questions from assignment 5 that I need to go over?
Mr. Clopton,
Yes, ma'am.
uh, may I go to the restroom?
Yeah. You don't have to ask me.
Can we go over number 29 from the fifth assignment?
From which assignment?
The fifth?
Which assignment?
5.
And what was the number again?
29.
Oh, that looks fun. Assignment 5, problem number 29. So, when I look at this, I immediately think that this is a rational equation. And when I'm dealing with rational equations, I want to clear the equation of fractions. I want to make those fractions go away. Gone, gone, gone. Make those fractions go away. We did this in assignment 2. So, a couple of quick notes. I bet that and I wrote that down wrong. That should be a 12. I bet that the factored form of this guy is equivalent to the product of these two factors. Let's see. What are the factors of 12 that add up to 7? How about a 3 and a 4? And how about we make them both negative? This is our LCD. This is the thing that we're going to multiply to every single term in our rational equation. Distribute that LCD to every single term. So, I'm taking some liberty here to cut down the amount of work cut down on the amount of things I have to write down. When I take this LCD and I distribute it to the first term, the x minus 3's cancel out, leaving me with x minus 4 times a 3. When I take my LCD and distribute it to the second term, the x minus 4's cancel out, leaving me with x minus 4 times the 5. When I take this LCD and multiply it to the third term, the LCD cancels out with our denominator, leaving me with x squared minus 20. distribute. And what I have here, in assignment 2, everything ended up being linear. After you distributed the LCD, you had linear equations, but this is now quadratic. Why is it quadratic? Because of the x squared. So how do we solve quadratic equations? We start off by setting them equal to 0. So I'm going to get all of my x's on one side. Let's start off by simplifying a couple of things I noticed. A negative 20 and a negative 20 on both sides, they cancel out. A 3x and a 5x make an 8x. So this becomes let's see. Hold on. There may be a typo in the answer key. Because right here, I'm getting, just looking at this, if I go through and factor both sides, we get an x minus 2 times an x minus 6 equals 0, which then means that x is equal to 2, x is equal to 6. And that contradicts the answer key. The answer key says x equals 1 and x equals 7. So question, did y'all get x equals 2, x equals 6 on this problem when you did it? What'd y'all get? Did I write down the problem correctly?
A lot of us got x equals 1 and 7.
Yeah, that's what the answer key says. So that's correct. What did I do wrong? What did I do wrong? I did something wrong. Let's see. Let's see if we can figure out what I did wrong.
Should you combine the like terms first and then subtract?
Well, it shouldn't make a difference. Because if you combine the like terms first, that would give you a negative 22 or 32.
Mr. Clopton, I think I found it.
What is it?
Okay, cause when you distribute the LCD to the equation, it should cancel out the x minus 4 under 5, but you canceled out x minus 4 and x minus 3 and left the other x minus 4.
That's what it is. That's what it is. that should be a 3. Which then makes this, so that makes then this a negative 15. We still have the negative 20. Which then, okay, so let's just regroup here. This becomes an 8x minus 27 is equal to x squared minus 20. That's it. Then you get x squared minus 8x. If you add 27 to both sides, that becomes a plus 7 equals 0. There it is. Thank you. Good eye. Good eye. Good eye. Yes, so it is x equals 1, x equals 7, and x equals 1. Yeah, that was my problem. I repeated the x minus 4. Alright, sorry about that. Does that make sense? Great. Alright, anything else?
Um, can we go over number 2?
Which assignment?
Assignment 6. Sorry about that.
Problem 2. Okay, so, um, we're going to solve by factoring. Why do I know to solve by factoring? Well, um, number one, the x to the fourth is telling me that this isn't quadratic. Um, it's not rational. There's no square roots. Um, so anytime I see some higher power other than x squared, anytime I see something higher than x squared, I say probably should think about factoring. And there's a GCF of x squared. Okay? With me to that point?
Um, sir,
Yes, ma'am.
how come it's only 5x, I mean x squared and not 5x squared?
Oh, sure. Why not? Yeah. Because my brain isn't 100% today. Um, so let's just keep going right here. We have a GCF here of 5. Sure. So 5x squared plus 4. Alright, thank you. Alright, with me at this point? Thumbs up? Yeah. Then I can set each factor equal to 0. So we get x squared is equal to 0, which just means that x is equal to 0. And over here we get x squared is equal to negative 4. So that means x is equal to plus or minus the square root of negative 4. Square root of negative 4 is an imaginary number, so x is equal to plus or minus 2i. So there's really 3 solutions. I don't care if you write it like this. The answer key has it of this form where you have x equals 0, x equals 2i, and x equals negative 2i. But if you just write x is equal to plus or minus 2i, I'll accept that as well. Alright, anything else in our last closing minutes?
No, sir.
You are good?
Yes.
Cool. Um, so, if assignment 6 is, feel like it's wrapped under your belt, please take a look at assignment 7, between now and Wednesday. That way we can address the questions over assignment 7. If you, we'll address that on Wednesday. If you still have questions over assignment 6, we can still do that on Wednesday as well. Hopefully, my plan is to be here Monday and Friday. Hopefully, I can start to feel better. Alright, I'm gonna go ahead and dismiss class. So, y'all have a wonderful rest of your day, and we'll see you on Wednesday. Take care. Bye.